Hi, this is a video I've been meaning to make for quite a while now. Manufacturers of audio recording equipment supply in their technical specification documents, often indeed the user manuals, what the equipment is capable of recording. Normally there are certain standard tolerances to this. In other words, the ability to record between two different frequencies, a low frequency and a high frequency, with a certain amount of dB loss that's allowed between these two ranges. The fact is that many recording devices can record well beyond these specifications, the published specifications, particularly where the dB loss isn't really considered any longer. In other words, you don't mind at how deaf the device might be or non-linear the device might be. You're just interested to see what its extremes are. And so what I've got here is a Technics stereo cassette deck, an RSB40, and a RSB40 is a machine manufactured around about 1985 or thereabouts, and it's on the market for a year. As can be seen from its front panel, the deck is a two-motor device. There's actually three motors in it, so they've missed an opportunity with that one. The deck can handle normal ferric tapes, chrome tapes and metal tapes. It has three varieties of noise reduction, which is a little unusual. It's got Dolby B, Dolby C and DBX. Now, for the purposes of this demonstration, I'm going to be using a particularly high quality metal tape. I don't use these very often because they're simply too expensive. And this one has seen its better days, to be fair. It's certainly it starts on each side, the tape's a little crinkled and crumpled and so forth. And there's a couple of dropouts on the tape because of it getting mishandled in a number of machines. So this is a TDK MA-XG. These tapes are quite pricey as new old stock, costing anything between £90 to about £120. Thus why I've only got one of them. A very heavy tape, very well made, and they're designed to keep the tracking of the tape very linear so it doesn't wobble about. So I'm just going to pop this into this deck. I'm going to be recording from the beginning on side B, which is where the tape is already wound to. So I'm not using any noise reduction, and I've got the setting onto metal tape. The balance is in the middle, and I'm getting ready to record. Now, what I'm recording, if I'll just move the camera over, I'm going to be sending a signal out from this signal generator, and I'm going to be recording that signal onto this cassette deck. The oscilloscope will show me the purity of the sine wave I'm recording, and also the frequency and the peak-to-peak voltage. And I've not tried this before, so I'm not quite sure how successful this is going to be. But over on my right I have a laptop, and this is connected via IP to the oscilloscope, and indeed to that end, if I go down to instrument control, I think it is, yes, there we can see a screen image of what's actually on the screen of the oscilloscope at the moment. So, and I'm recording this using the Microsoft gaming capability that's built into Windows 10, which does screen recording. And I may or may not use that footage in the final edited video, depending on what comes out. So, the oscilloscope is a Siglent SDS1204XE. It's a 200 megahertz bandwidth scope, it can record as up to 1 GSA, or if it's in quadruple channel mode at 500 meg SA. It's a 4-channel device. I'm just using channel 1 for the purposes of this video. Just going to zoom in a little bit. So to start with, I'm going to just set up my probe. This is not a probe I've normally used. In fact, I've recently dug it out of the loft. And I'm just going to calibrate this probe because I've never used it on this oscilloscope at all. So I'm going to set the oscilloscope to default. The probe I've got set as times 10. That works the opposite way around to what you think it does. So it's not magnifying the signal by 10, it's attenuating the signal by 10. I have to tell the scope about that attenuation, so I choose the channel which I'm on, 1, and here it says probe, and when I select this probe button here, which is like the hot button, I can select times 10. That's now using the correct calibration of the probe. And if I press auto setup, hopefully we should get a calibration signal coming up. That's miles out. Basically these lines should be flat. So the trimmer on this particular scope is actually on the BNC. On some other probes, the trimmer is actually on the end of the probe itself. As you can see, I'm just flattening this out, and I think that's probably about right, thereabouts. That would certainly do for what I'm intending to do. So the probe is now calibrated correctly, and what I'm now going to do is to remove the probe from its calibration terminals, and I'm just going to connect that to the line input socket, which has got a cable going to it. This is the line input socket of the cassette deck. It's proven to be a little problematic, as these things often are. There's too many crocodile clips. I'm not going to bother to show this to the camera on this occasion. In fact, I might edit this bit of the video out if it's too poor. Okay, so that is that. On the signal generator, I've got this ready at 6 Hertz, and the reason why I'm starting at 6 Hertz is I'm going to be slowing it down to 1 Hertz, and the scope has difficulty locking onto 1 Hertz straight off. So I'm going to switch on channel 1. I'm just using again 1 channel of the signal generator. That's now on. You see from the scope that I am getting a signal on the scope. Not getting a signal. Yes, we are finally getting a signal on the laptop as well. And I'm going to press auto setup. This gives it a chance to try and lock onto that signal. And this is the 6 Hertz signal. And again, if I go just over to the laptop, you might be able to see just about the sun reflecting off it, the same signal as I'm seeing on the display. Right, just knocking everything inside here. So there we go. And I'm now going to slow this down a little bit. So I'm going to just drop this down to 5 Hertz, 4 Hertz, 3 Hertz, 2 Hertz, and 1 Hertz. I'm just going to change the resolution of this so that you can see it on the screen. Acquisition, of course, is taking quite a long time at 1 Hertz. So we're recording 1 Hertz, or we will be. So I'm going to pop this into record. I'm starting off with the volume level at 0. You can't see what I'm doing, so I'm going to zoom out. So the deck is in record pause, the deck is now in record play. I'm just waiting for the leader to wind off. The record level is 0. Bit of a peculiar way that they make these potentiometer controls. The level it's at is where the arrow is, not where the knob is. Same again, looking at balance, it's where the little arrow is, not where the knob itself is. Okay, so we have 1 Hertz, and I'm just going to pop the volume up, and I'm getting nothing at all showing on the display here. So that's 1 Hertz. I am recording, but not seeing anything on the input of the cassette. So I'm now going to go to 2 Hertz. Three Hertz. And we're beginning to see a bit of movement here on the recording level. It's flashing, funnily enough, at 3 times a second. 4 Hertz. Hertz. You see, as I change frequency on the signal generator, I get a blip of output. The amplitude, by the way, is set to 1.5 volts on here. I'm just going to put on the maths measurements. You can get measure, and I should be looking at type. That's better. And I want to basically have peak to peak, period and frequency. So that's all good. So now you can see I have peak to peak voltage 1.58 volts. I have period of nearly 200 milliseconds, and I have a frequency of 5 Hertz. Okay, let's start ramping this up fairly rapidly. 6 Hertz. 7 Hertz, 8 Hertz, just about hitting the Dolby level on record. 9 Hertz, I'm just going to drop the record level down a touch, so it's just the Dolby level. 10 Hertz, and again I'm going to adjust this. 11 Hertz, 12 Hertz, 13 Hertz. All of this is completely out of spec of this machine. It's not designed to record any signals whatsoever at these kind of frequencies. 15 Hertz, 16 Hertz, 17 Hertz, 18 Hertz, 19 Hertz, 20 Hertz, 21 Hertz, 22 Hertz, 23 Hertz, 24 Hertz, 25 Hertz, 26 Hertz, 27 Hertz, 28 Hertz, 29 Hertz, 30 Hertz. Now going to jump up to 50 Hertz. And as you can see, I'm at 50 Hertz, 1.56 volts peak to peak. And I'm now going to jump up to 100 Hertz. (200 Hertz), 300 Hertz, 400 Hertz, 500 Hertz, 600 Hertz, 700 Hertz, 800 Hertz, 900 Hertz, and 1 kilohertz. And again, I'm now going to start jumping up 2 kilohertz, 3 kilohertz, 4 kilohertz, 5 kilohertz, 6, 7, 8, 9, 10 kilohertz, 11 kilohertz, 12 kilohertz, 13 kilohertz, 14 kilohertz, 15 kilohertz, 16 kilohertz, 17 kilohertz, 18 kilohertz, 19 kilohertz, 20 kilohertz, 21 kilohertz, 22 kilohertz, 23 kilohertz, 24 kilohertz, 25 kilohertz. It is now well beyond the specification of this deck. 26 kilohertz, 7 hertz. So we're seeing, it's not wonderful, but there's 7 hertz. So, and there was something there before. Seven hertz. Seven and a half hertz. So it's getting 7 hertz. Remarkable. 900 hertz, kilohertz. Two kilohertz, 3 kilohertz. Four kilohertz. Ten kilohertz. 11. 12 kilohertz. 13. 14, 15, 16, 17, 18, 19 I think, bit of distortion, 20, 21, 22, 23, 24, 25, we've pretty much lost it. So we did get a reading at 25 kilohertz. And we're still seeing something, it's just that the signal now is sufficiently warped, as it were, that the scope can't do anything with it.